everyone. Welcome to latest in Bitcoin Tech session. Today, the discussions are based on newsletter number 372. Um, it basically most of the newsletter has like mostly on is based upon question and answers with regards to op return and stuff. um, so I thought we'll go over the different configuration options that are available in the two implementations, core and knots. So that I was also trying to understand how all these configs interplay and what are all the effects these configurations have across the node. We'll try to cover. There are more than 110 config options available. So we can't be very exhaustive, but I have picked a few areas or groups which are relevant uh, for our discussion, and let's try to understand what these configs do in your node and how they are different. What are the differences between these configs in core and knots? So that will be the bulk of today's discussion. If we have time, we'll go over a recent research that was made, that was conducted to study how many of these reachable nodes have set their or revised their minimum transaction relaying fees from 1 sat per V byte to less than 1 sat per V byte. So yeah, if we have time, we'll try and look into that. So the node configurations, we can at a top level, we can categorize it into different segments. So if you can see, um, the configurations can be largely categorized into network options, policy options, mining related options. Then we have resource management related options. We also have RPC command related options, and some debugging and logging options, storage, of course, chain selection, wallet, and validation options. So I think if you I have tried to pick few relevant things in network validation and policy. That's broadly the broad classification that we'll try to cover. Uh, of course, there are other options too. If you are interested, if anyone is interested into going deep into those config options, we can also try and look into it. So in the network, there are a bunch of stuffs. We'll try to just but the issue to note here is that most of these options are common between core and knots. There is no difference between these config options between core and knots. Uh, like the first one in the network option is like add node. If you are if you want to if you are particular about adding a specific node to your node as a peer, then you can use this config. You can just type in the IP of the node that you want to add as a peer, so that will add it. Then uh, there is this but the difference is that it will add this node as a peer to your node, but it will also connect to other peers via its other methods of connecting to its peers. But if you don't want to do that, and if you want to just make your node speak to only a few nodes that you trust, or that you want them to talk to, then you can specify those in the with the connect config. Then you have listen config. So what this config will does is that it will accept connections from outside. The default is the default is set to 1. So only if you can accept connections from outside, you'll be able to like share. And here the network gossips that is happening outside your node. So that's enabled by default. Uh, then you have configs for port. So the default is 833 for mainnet and 1833 for testnet. Then you have this config for max connections. So fun fact, like at any given time, your node can like connect to like 125 PS. So the maximum connections that it can make by default is 125, but I don't know how much is the maximum, like how till what limit we can increase it. I'm not very sure. So that's one config. Then you have this DNS seeds. So you have a list of seeds that are hard coded into the code itself, and your node like goes into those DNS seeds and looks for IP addresses of peers to which it can connect to. So this is enabled by default, and that's how when you like spin up a fresh node, that's how that's how your node finds its peers and connects with them. Then you have this fixed seeds. um, so this is also like provided as a backup. So if for some reason all the DNS servers sort of fail and you're not able to find a peer using the DNS servers, then you have a list of IPs that are also hard coded. So your node will try to connect to those IPs and then try to get further information about peers in the network. So that's the fixed seeds. But the problem is fixed seeds IPs are like hit and miss. They can or they cannot be active. So the primary mechanism that your node relies on to connect to peers is via the DNS seed DNS seed option when it starts up as a fresh node. Then listen onion is a config that is enabled by default. That's how your node runs behind a tar. um, these are all other stuffs that we like don't not of much interest to us now. um, so this one discover config. uh, this is of like some interest to us because this will enable your node to be automatically detected, automatically detect and advertise its own external IP address to the network. So by default, this is also one set to one. This is with this config. If you turn this config off, it will be like very hard for peers from outside to talk to your node unless and until you establish a connection with that peer. They won't be like able to talk to you. uh, Other than that, um, so yeah, these are the some basic network options that I found relevant. Now let's move on to the policy options. So the famous or controversial data carrier size config. This by default now since core v30 it has been like set to 100,000 bytes. Knots it maintains a default of 42 bytes. So this specifies a maximum maximum size of data in the data carrier field, that is operator field, that can be relayed by your node by your node. This data carrier is a toggle switch for this data carrier size. So you enable it, then your node will transmit operator containing transactions. If it is disabled, your node will not transmit operator containing transactions. Permit bar multisig. This is another config. There are like cases where people use bar multisigs to like push data into fake public keys. So nodes disables this bar multisig by default. Core has it on, just to support legacy transactions that might be actually using a bar multisig, but that's statistically like very low number, and I don't think anybody else is using bar multisigs for genuine multisig operations. Then we have a min rate txv. So this is the setting, like currently if you are running any version less than v30, it will be set to 1 sat per vbyte. So your node will not even will not transmit any transactions that pays a fee of less than 1 sat per vbyte. uh, since v30, this has been like changed to zero point 0.1 sat per vbyte, and knots also has in the latest version changed it to 0.1 sat per vbyte. So this is more of a reflection of what the network state is as of now, since there is not a very healthy demand for block space from transactions. The average fee rate has kept on falling down, and it has like gone below 1 sat per vbyte. So that's why it like now makes sense to reduce this min relay txv config defaults. Then you have this incremental relay fee. This is like on top of whatever relay fee, whatever the fee. Like let's say you are at a zero point 0.1 sat per vbyte. You The minimum top up or minimum upgrade that you have to do is add another 0.1 sat per vbyte. You cannot like add. You cannot like go from 0.1 sat per vbyte to 0.15 sat per vbyte. So that's not possible because of this config. So this is by default set to 0.1 sat per vbyte, since core v30 and the latest knots release. So that's the incremental relay fee. Then you have the block min txv. So this basically sets the minimum fee rate that a transaction has to pay to get included into the block template. So this is related towards mining. This is more related towards mining. Means it quantifies what is the minimum fee that a transaction has to pay in order to like even be considered for being included in a block template. um, so that's it by default. Like now it's since uh, the default min txv relay has been reduced to like 0.1 sat per vbyte. This this default has also been reduced to 0.01 sat per vbyte. Um, then we have dust. There we have this dust relay fee config. Uh, it is like basically this is set to default by 3. So how the calculation goes is that your node will like calculate your transactions output size and add it to its input size and multiply it with this dust relay fee. So that will give you a threshold. Once this threshold is arrived at, then it will decide based on this threshold which transaction is dust and which transaction are spendable. That is economically viable to be spent. So yeah, this multiplier in your config decides which transaction that you compose is economically viable and is above the dust limit. Then we have max script size. So this sets the limit on what is the maximum script size that a transaction can have. Um, it's the maximum transaction script size. It's set to 1650 bytes, and it's hard coded in core. Um, but this you can like config this configuration in knots. So that's the only difference. So in knots also the default is 1650, but you can like play around with this. There are like research as to fingerprinting or showing some patterns related to how the script size has some relation to the type of transaction. That is, if it's an ordinal or if it's an inscription or if it's a rune, tend to have a particular pattern of script sizes. There are some efforts to like develop filters based on the script size. Then we have a series of not specific, um, not specific policy configs that you can set. These are not available in core. So the first one is reject parasites config. So this is a filter. It enables filtering of a lot of what is called as parasitic transactions, that is non financial transactions that are trying to use the network. So it includes ordinals, inscriptions, runes, stamps, DNS systems. Like there are protocols that try to put in DNS info on the blockchain, and there are like protocols that are trying to put Noster info on like use the blockchain as relays. And other non-monetary uses of Bitcoin. So this is a like a overarching reject parasite config is like a wide net that is cast to catch all these things. Um, but if you are like if you think that this net is too wide, uh, basically how it filters is it has the code has patterns, like ordinals has a certain pattern of script, and that is like used to say that whether this transaction is an ordinal or is it an inscription or rule. So all these, if all these conditions are hard coded into this config, so if this is enabled and if the node encounters any of these patterns, then it will not relay the transaction via its mempool. So that's this. But if you feel that this is too wide a net and you want to like sort of narrow it down only to tokens, Knots also gives you a reject token config. This is specific to BRC20 runes and stamp. So it has patterns of BRC20 runes and stamps embedded in it. So if you enable this, you will be able to filter out these tokens, token based options. Um, these are all like default. They are set to 0 in your knots. You have to like go on and enable these things if you are interested in policy filtering. The only thing that is enabled by default is that is enabled by default is this data carrier size 42. So that's the only thing that is enabled by default in your knots, and you'll have to like go and toggle these things if you want advanced, if you want to use these advanced filters. Then you have bytes per sig op strict. So this is another a DDoS prevention filter that is specific to knots. So what it does is that it sort of measures the ratio between your transactions size and the number of signature operations that it performs. So by default, it's like this ratio is set to 20, and if this yeah, the idea is that if this ratio exceeds 20, then it is more likely to be a it is more likely to be a spam, and that's why like or it's more likely to be a denial of service attack. So those kinds of transactions are not transmitted. uh, then you have data carrier cost. So this is another like a roundabout way of discouraging putting data on the blockchain. So what this config does is that basically it looks at transactions that arrive in the mempool, and it like checks if there are any operator outputs in a transaction. And if there are any operator outputs in a transaction, what it does is that it sort of multiplies the multiplies the transactions size with this multiplier, and it will allow uh, transactions only if they are paying a certain fee rate, um, so that naturally like transactions that have operator in it gets multiplied with a number, and they will have to like this knots node will transmit only transactions that are willing to pay a higher fee rate for transactions containing these operator outputs. They will not relay these transactions if they pay a lower fee than that is decided by this config data carrier cost. So by default it's like 1, which means it's disabled by default. If you want to like penalize or don't want to transmit, or if you want to, or if you decide that you are willing to transmit op return based transactions, transactions containing op return, but only at a higher fee rate. So if you think that fee rate is the only true filter that can be effective, then you can like use this config. You can put a 2x multiplier, 3x multiplier, 2.5x multiplier, whatever you think that data containing transaction has to pay, you can put that in. So this is a very like in my opinion an effect, or at least it's an effective filter. So there are like no you don't go into patterns and checking whether this pattern exists or not. You just simply see that if the transaction contains data that is operator outputs, then you just want that transaction to pay more fees. If the transaction pays more fees, then you like transmit it across. So these are not specific policy configs that are available. If like I'll wait for a few minutes, a few seconds, if anyone has any thing to add, or will
I had one question uh,
yeah,
regarding the submission of transaction for with zero point 0.1 sats per vbyte. How do
yeah.
you do we do the transaction? Because in Sparrow wallet, the minimum fee, like it is
Yeah.
one sat per VByte. So how do we do the transaction?
Yeah, right now, no wallet is supporting less than 1 sat per VByte. So, if you want to you want to compose it, then I think you have to do it manually by you. I think you have to import your public, like you have to run your own core, the core V30. Then you'll have to import your public private key pair for that UTXO at least into core, and then as a into core and into that wallet, and then you'll have to manually compose the transaction using RPC commands.
Okay, okay, okay.
Yeah, that's the only way as of now, until all wallets sort of shift. But I think they most of the wallets are like waiting, so they don't want to like get into reduce it to point 0.1 sat per VByte, and suddenly the fee market spikes, and like they don't want to risk like killing a lot of transactions.
I was just checking the Sparrow wallet. The
Yeah.
fee range, it starts from one, but in fee tab you can manually type it shows by default like 250, 300 sats. But if you type 15 or 20 sats, it shows in the rate like 0.14 sat per VByte. So that way you can
I-
toggle.
Is it taking? I don't know. I have.
Yes, it is taking.
Okay,
But
okay.
Bala, I had a question. So even if he puts it, Amol puts it in 0.01, only the nodes which are version 30 or not the latest version, only those will relate. So technically, the
Yeah,
transaction being relayed is also not confirmed. So you won't be sure your transaction will relayed or not.
yeah, that is also true. Only if you are like running a V30 node, and like best thing is that you should run a V30 node at least. Uh, if you even if you don't run a V30 node, then I think it will not be relayed by your own node. So best thing is to run a V30 node and then use Sparrow to compose and send it across.
Okay, okay, got it, Bala.
Yeah,
Okay, so Bala, one more.
but in the fee, it will enter only. You can only enter sats, so you have to calculate manually, I think. Am I correct, Amol? So you have to calculate
Yes, yes,
for zero
yes.
point 0.1 sat per VByte. You have to calculate the weight of your transaction. Then you have to put in the right sats so that you get zero point 0.1 sats per VByte.
So I was just taking one transaction. The fee is coming 140 sats, which is as per
Okay.
one sat per VByte. So if I divide it by
Hmm.
10, so I just remove 1014 sats, so it comes to around 0.1 sats per VByte.
Yeah. Okay. That's a nice way to calculate. Yeah.
Yeah, but on the safe side, add to 4 or 5 sats extra or whatever, 10% more to make sure that it goes through.
Yes, yes.
Yeah, if you are putting in any fee rate less than 1 sat per VBIT, then you are at the mercy of finding a V30 node and trying to get your transaction across to a miner.
Yeah, got it.
So, Bala, one more question. So, let's say Amol makes the transaction with the divided by 10 and sends it. So, are Sparrow wallets and other nodes directly? So, whenever a new version of Core or not, whatever implementation they're running, whenever there is a new version available, did they automatically convert to it, or they wait for converting their own nodes, the wallet themselves?
I don't think anybody does auto upgrades in this space, but I think Sparrow in their list of nodes they will have a mix. I think of all at least 2 3 versions they will have in their own list. That's what I guess. I'm not sure, but
No, no,
definitely nobody auto upgrades.
yeah, no, I asked it because even if Amol makes it and the Sparrow wallet themselves don't have a version 30 implementation, version number,
Yeah,
then the
yeah.
Sparrow wallet itself won't transmit the transaction, if as you said.
Yeah. But you can like go into your Sparrow Wallet settings, into the server option, and then probably you can, if you know some public servers that are currently running V30, you can like specify it, and your Sparrow Wallet will try to connect to it, and then you can be sure of transmitting it.
Okay, thanks.
Yeah. So if you go into the server settings, Sparrow by default lists bitcoin.luke. So like if you are if you want to like use knots, you can select that. That will go through a knots node. Similarly, it also has set for privacy's fulcrum. I don't know what he's running. Like you'll have to check into it. Blockstream.info is one. Electrum.blockstream.info is another. Bitcoin.luke, definitely not V30. But if he's running latest knots, then that also has the zero point 0.1 sat per vbyte. So yeah, you can like check the options available to you and figure out who is running V30, and if they are running V30, then we'll probably send it across. So yeah, that's about this policy options. Then we can like look into this validation options. Uh, so you can also config what your node validates. You have some control over it. So the first option is assume valid. By default, it's set to 1. This assume valid config is used to speed up initial block download or IBD. Uh, what for every release, a particular hash will be hard coded, so that when this option is enabled, your node will assume till that particular block hash, every block is valid. So it will not go into and do the full verification, but it will do a partial kind of verification. So what is done is that it will check the proof of work, it will go into the block header, it will double SHA the block header and check whether that double SHA is less than the difficulty at that time. um, and it'll also check whether the UTXO states are consistent. It'll also check whether the block structure is properly formed. Then other consensus rules with respect to the transactions, such as fees, that is input, output plus fees equals input. All those consensus rules it will check. It'll also check the transaction ordering and structure and stuffs. What it will not check is that it will not go into the scripts. It will not go into the signature verification part of each and every transaction. So this is assume valid is enabled by default in core and knots. This is there to like verify or speed up your IBD. So it's basically you are trusting the node node operators, like the node devs. That's a trade-off. If you don't like it, you can turn it to 0, and your IBD will probably take much longer. Much longer. Then you have this assume UTXO. Uh, this is like you are also bypassing the UTXO set verification and all. So if you enable this, you can like preload a snapshot of the UTXO set uh, at a particular block height. So by then, like you are assuming that the UTXO set is correct and intact. You are not going into verifying the UTXO state. So this is another assumption that you can enable or disable. By default, it's disabled. Then you have this check blocks config. So every time your node restarts, not just during IBD, even after IBD, let's say you shut down your node and then you restart your node. What this config is comes into play. So what it will do is that it'll check the by default it's set to 6. That means it will check the latest 6 blocks that it has with itself, to make sure that the block, the database behind the block, the change state folder, and all those stuffs are correct, or whether they have not suffered from any corruption of that sort. It will check for that. Check that's this check blocks config. Then you have this check level config. So you can whenever check blocks is executed, you can control what are all the like what are all the parts of your block that this check block can go into and verification. Remember that this is particularly linked to this check blocks. That is when you when you close or shut down your node and then restart it again, only then these configs are triggered. So level 0 means it does do any validation. It just reads the blocks from the disks and assumes that these blocks are intact and or verified. So that's level 0. The second level is block validity. It just checks the block validity, that is headers, proof of work, and the structure of the block and those information that it checks. Then in level 2, it adds much more complexity. Like from level 1 to level 4, it's a full verification step. At level 4, what it does is that it tries to reconnect. Like it assumes it sort of simulates a chain rearg, and then tries to reconstruct the block from that point onwards. So like if level 4 is when you perform level 4, then you are like very sure that you have all the data with respect to the chain in your hand, and you can confidently work through any reargs that will be coming your way. So handling reargs is quite complex, and you need a lot of data apart from just the block data to handle a rearg. So that's the level of checks that goes into these two configs. Uh, then you have also this check mempool, very check mempool config. So this also like specifies uh, the mempool database, which is stored as a level DB. No, the UTXO is stored as a level DB. I'm not sure in what data structure the mempool is stored. So this mempool data structure is verified for its consistency uh, to uh, there is a frequency at which your node goes into the mempool data structure, checks it for its consistency, and detects for any corruption is present or not. So like these are all the validation options that you can configure. These are the same, and they're common to both core and knots. So yeah, like if you have any questions or discussions over this, I'll wait. Otherwise,
Bala, I had one question regarding the previous section where it was mentioned as listening nodes. So, what are listening nodes and uh, other? Are there any other type of nodes? I would just wanted to briefly explain.
yeah, basically, by default, your node doesn't port forward. So that means your node is there is no IP on the clear net which with which somebody from outside can directly connect to you. So you have to enable by enable port forwarding within your node in order to make that possible. So what that means is that now we are seeing lists of nodes like v30 is 10%, 14%. So what these specifies is these are publicly reachable nodes. That means you have configured port forwarding, and you have like enabled your node to be visible from the to the outside. So what these node scanners will do is that they'll send a ping to particular IP in port 833. So if it gets a relevant Bitcoin like the protocol message back, then that pinging node will start to interact with it and get more information from it, like which version it's running, what's whether it's pruned or full node and those kinds of things. So by default, nodes are not configured to be discoverable from outside. But like other peers can connect to you because you exchange information about your IP with the peers that you connect to. So once you become a part of the network and you become a peer in the network, the other peers in the network will know you because you handshake with them, and then you send information about how they can find you to your peers. But without someone establishing a connection with you via this P2P network, they can't just like that ping your IP via port 8333 and connect with you. So that's the difference between publicly reachable. That's what is meant by a publicly reachable node.
Okay. Thank you, Bala. In my node, there are default like 10 outgoing connections and one incoming connection.
Yeah.
Is that related to this listening node? Like I am limiting
Um,
it.
No, your what that number specifies is that like when you first did your IBD, you would have gone to the DNS server available, and that DNS server would have given you a few IP addresses. And what your node will do is that it will try to come contact those IP addresses. So once it establishes contact with those IP addresses, now your node will also pass information that you are a Bitcoin node and you are using this IP. My IP is this. This information will be saved by that particular peer. So and it will pass this particular your IP to its peers. So your details, the information as to how to connect with you um, will like float among the peers with which you connect. So by that way, there will be incoming connection and outgoing connections to your node. But but your node is not in any way publicly reachable. Like unless and until I somehow become your peer via this P2P network, I will not be able to speak to you or communicate with you. Uh, if you want to like broadcast or say that I am a Bitcoin node, then you will have to do port forwarding, set up port forwarding so that the public IP, you will have a public IP that can be reachable by normal by pings. So when these sites that list publicly available nodes, they'll search for IPs and send Bitcoin P2P messages for various IPs in port number 8333. So if they get a relevant reply, then they'll list that node as a Bitcoin node. If they don't get Bitcoin P2P message reply back, then they'll discard that particular IP and they'll move on to the next IP.
Okay, okay, Bala. Thank you.
Yeah, but
Yeah.
Bala, when you say the default is 125, is it connected to 125? Because in the articles and the book, it's written that so it's according to the hierarchy. So the nodes also have rankings. So in the core itself, technically, you connect default to around 5 or 7 nodes when you just start your new node, and after
Yeah.
that you can increase it to Bitcoin depending on the ranking. The 15 there are
Yeah.
15 nodes which you connect to physically, and then the transmission is done through different nodes. So you don't connect to 25 itself, right? 125 by default.
No, you don't connect to 125 by default. It is the maximum number of connections that your node can have. As you said, there is a ranking system, and there is an algorithm behind it, and that is to make sure that you are like not you don't stick to one guy and just believe that whatever that node feeds you is the truth. So you have to like talk to different people in order to uh, come to a come to a solid consensus about what the chain is.
Okay, got it. Thanks.
Yeah. So yeah, that's the policy, and there are like few mining related configs. So Knots has two specific mining related config. So I'm not sure which miner is using a Knots node because it means of course Ocean should be using it. Apart from Ocean, I don't think any other miner will be using a Knots node because that means like they'll probably lose out on a large chunk of data transaction. So this block max size config is used to like set the maximum bytes of blocks that your that your mining node will create. Like it's a you basically set a limit on the block template, maximum amount of transaction data that can be included in a block template, so that you can specify with this block max size. But I'm not sure like why Luke Dasher put this in. What's the history behind it? I'm not very sure, and I don't think anybody is using it. By default, I think it's disabled, and even Ocean doesn't use it. That's what I think. Uh, then you have this block priority size. So earlier versions like before v I think v was 0.50 0.15. They had this idea called as coinage priority. That is so it's a the idea is that if you are spending old inputs with very high value, then you sort of get a preferential treatment, and you are even if you are even if you pay a lower fee, but you can find you can like find your transaction in the block because there is some reservation for it. So that's called as coinage priority. I think it's there in Knots. Just I think just because Luke didn't have the time to remove it, or I don't know why why he has this option in there. I seriously don't know. So yeah, that's about it. Then you have resource management stuffs, and like there are a lot of others. I think we can like if you want, we can go over all these things in detail in the next session. Yeah. Now we'll just have a look at this research as to how much of these nodes are like have picked up this zero point 0.1 sat per v byte transaction, and what is the likelihood of a zero point 0.1 sat per v byte transaction being broadcast. So for that, I will have to share. So so what this research is about is that a developer crawled the whole network just to record the minimum transaction relay fee that are advertised by these reachable nodes. So again, here these are all reachable nodes. As we discussed earlier, these nodes should have um, port forwarding enabled in them. Only then, like, they'll be publicly reachable. um, and all these researches are limited to publicly reachable nodes. You can also like go to your you can like get your nodes internal IP and go to your routers page, and then put that nodes internal IP in the router, and then you'll get a public IP that like can be public reachable from outside. So there is a little bit of work that you have to do in order to make your node publicly reachable. If you do that, your node will also respond to all these uh, crawling messages. So so what has been found is that so yeah, basically you can see there are like no, all nodes are not the same. There are a bunch of networks that nodes run on. Few nodes run on tar, few nodes run over IPv6, few nodes run over IPv2. um, so basically in this research they have done, what they have done is that they have performed two scans, on one on 10th September and one on 15th September. And like you can see um, like on 10th September, like 2900 odd nodes over the I2P network were having were responding. And 9000. So as you can see, the most number of nodes run on tar. So like on 10th September, 14,000 nodes approximately were available over tar, publicly available over tar. So these are the numbers. So among these things, what are all the minimum relay fee that these nodes reported? So you can see 1000 is 1 sat per vbyte. So no, sorry. Minimum relay fee, no filter sent. What is it? Is it vbyte or so yeah. So in total, the reported minimum relay fees, like I think varies from 1 to 1000. Um, is this sats per vbyte or not? She has not mentioned any thing whether it's sats per vbyte or not. So 1000 seems to be most nodes seems to be stuck at 1000. I think they should be 1 sat per vbyte. Um, and as you go, 100 is zero point 0.1. No, it should be. Um, is she measuring in milli sat
No,
per?
Bala, I think so. That is the total transaction size. So that is the, I think so. That is the fee which your transaction is sending. So normal transaction average is I think so 1,000. That is I think so fee. 89%, yeah. So if you make in
No, no.
any wallet,
No, this is reported minimum relay fees. That means this is min. This is a parameter from the node in the
yeah.
config that you set, min tx relay fee. So 1000, I think 1000 should be 1 sat per vbyte because most nodes have this setting. And I don't know who has this huge number. 84 nodes seems to have this huge number. So that's like 917,000, no, 9 million. 170,000 sats per vbyte. I don't know what this is. So yeah,
Maybe it is set. Maybe it is set because they don't want to relay any transactions. They just want to store the
yeah,
blockchain. Like whatever new blocks are
yeah,
coming, they just add that.
yeah. That's also true. If you set your min delay TXV to a very high number, I think yeah, as you said, you will not transmit any. Basically, your mempool will be empty. So you just store mind. You just have a copy of the block. That's it. So this is the whole situation right now. As we were discussing earlier, it's like very hard to transmit uh, um, uh, zero point 0.1 sat per vbyte. Even among publicly reachable nodes, a majority, like 89% of them, have not switched from 1 sat per vbyte. They are like still at the at this 1 sat per vbyte. Uh, so yeah, there are very little number of nodes that are like uh, relaying for very few sats per vbyte. So that's the situation of the network with respect to min relay fee right now. Um, hopefully, like if more people are using with I don't know new knots versions, they'll these numbers might improve. Yeah, that's that's about this research. So there are discussion about spy nodes. So if a node does not send you a fee filter information back, then it's probably a spy node. That's what the idea is. I don't know what a spy node is. Um, so when she checked these IP addresses of these nodes, which did not return a fee filter, she found out that these nodes come from the same subnet. Um, so yeah, even among publicly available nodes, we cannot be sure which are harness nodes, which are run by normal plebs, which are like run by interest groups. We can never know. So whenever you see those numbers of adoption that are being like shown by both sides, I think like we should take it up with a grain of salt.
So, so Bala, this is your programmer stuff. So basically, 1000 is in your configuration while programming, it's 1000 per kilo virtual byte. So for a
Okay,
human readable,
KB.
it comes to 1 sat per V byte.
Oh, okay, okay, okay.
But,
Got it, got it. So,
so your
so this is one
programming,
sat
yeah,
per.
so the programmer's done it that way.
So this is one sat per vbyte, and all others are less than one sat per vbyte.
Yeah,
And this is some crazy number that says that I don't want anybody's transaction in my mempool.
yeah. So everything is per 1 kilo virtual V byte. So
Okay,
1K
okay,
V byte, everything.
okay, okay, okay. Got it, got it, got it. So yeah, that these are the two things that I had to like share with you guys. Um, I I don't know if it was any of any help. Maybe um, um, Rajendra sir, did you find it? Uh, did you find anything new today?
Yes, yes. It was good session. It was good.
Bala, I had a question. So, in the op return multiplier fees, is it dependent on? So, is it default by one? So, we see one into that means whatever fee the transaction has for op return, or the
Yeah.
default can, or is the default something different? And plus, does it now affect the number of op returns have also increased in the Bitcoin core? So, that also affects the core version also,
No, no, that
or not
data
version
carrier
also?
cost. No, that is a particular policy config called as data carrier cost that is specific to knots, and it doesn't. What the idea behind is that I am ready to transmit data containing transactions only if you pay a higher fee. So don't come to me with a data carrier transaction that pays the normal fees. You if you are willing to pay an extra, let's say 2 times or 3 times, That's the multiplier. If you are willing to pay an extra, then I am, as a node, I am willing to transmit that transaction.
Yeah, I got it. But in the core, the knots, it's written default is one into
Yeah,
whatever.
yeah, its default is one.
So that means
That's what is.
whatever fees the operator has.
Yeah, that's the normal fees.
Yeah, that's what I thought. So you have to change
Yeah,
it manually. And does it
yeah,
also affect the number of operators? Now they have changed, right? You can have any number of operators for Bitcoin Core. Does that also, is there some change going to be in that, or the default, it will, the Luke Dasher will decide what to do with it? The
no,
number of operators in a transaction.
that is only specific to core. Your knots node will not transmit a transaction that has more than one operator in its output. So that stays the same. It can have
Oh,
at the most one operator output, and by default that operator has to be less than 42 bytes, and by default, if you are paying the correct fees, like the exact fees that your transaction is supposed to pay, then your knots node will transmit it.
okay, okay, got it. So core
Eh,
knots hasn't even touched anything. They haven't changed at all anything regarding the operator numbers.
no, no. It's still one operator per transaction, and 42 bytes per operator is the limit, default limit in knots.
So, Bala, so probability wise, what is the minimum number of implementations or version number you need for a transaction to be added to a block? So let's say only 5% of the versions are which allow you to have op returns or whatever new things you want in the blockchain. What is the
Hmm.
probability of the your transaction being transmitted to the whole
Finding a
network?
miner.
Or yeah,
Finding a
finding
miner.
a miner. Yeah.
I have never come across such numbers, but yeah, there should be some number. But the problem is nobody can um, like experimentally find out what that number is, because there is no way for you to test on, like you can only ping nodes that are like publicly that relay their IP addresses and are publicly available. Uh, Other than that, it's up to your node to handshake with whatever peers that it comes in contact with, and exchange information about its own peers and it peers own peers, and then rank it according to the algorithm and try to make connection with it. So I don't know how you can like experimentally fix a probability number from outside.
Okay.